Well, welcome to the June 13th, 2023 session of Tangerine SDR and Hamside technical session. My name is Dave, KV0S, and this week I've been mostly working on K9Q radio and documentation. So I've been doing that. Had a few other duties to do, but that's taken up most of my time. And I'm making progress, but it's a slow slog. So we may get into some of that later, but I think it'll be a week or two before I have much to show. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. So I'm on the road this week. I'm here with Rachel in Blacksburg, Virginia. We're in the land of the Hokie Bird, Virginia Tech. So go Hokies, yes. So I took five Scranton students, one Case Western student, and 3 Scranton faculty to Virginia Tech to spend a week at the SuperDarn laboratory here, where they're working with my PhD advisors, colleague from grad school, and they have 4 Virginia Tech undergrads here as well. And they're spending an intensive week learning about SuperDarn radars and how to use SuperDarn data. And they're learning all about Blacksburg culture. So I think we're having a good time. So yes, back to that.
Very good. Next on the list is Michael, AAAK. Go ahead, Michael.
Oh, thanks. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list, we have Bill, Engelkey, AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, on this project, the main thing I did this week was prepare an image of my grape that runs GNU radio and DRF and all of that. And I prepared that and went into the university and put it up onto the UA box system. I found out it's my connection, my internet connection is not capable of allowing me to upload 7 gigabytes. So it just crashes. And other than that, the only thing I did this week was to work the ARRL June VHF contest and worked about 280 6-meter and 2-meter FT8 and SSB contacts. That was the weekend. So that was kind of fun. Worked at VUCC in a single weekend. Anyway, back to Ned.
Very good. And next on the list is Dave Witten, KD0EAG. Go ahead, David.
I hope you can hear me. I don't know.
Yes.
Can you? Yes. Okay,
Yes.
You can. All right. All of a sudden, my camera ceased working with Zoom. So I don't know what its problem is, but my new camera. But I've been working on some stuff related to this project, to the Clementine or whatever one wants to call it activity, and trying to gather information and items and communicate with people a bit. That's about it for right now. Talk about other stuff. I have some other stuff. I have a thing in the chat. Some of you've seen, but it's a link to the to some notes. So about this. So I'll turn it back over.
Okay. And I have been talking to Dave about that, and he's been moving forward on these notes. He compiling quite a bit of information. Next on the list is Franco K4VZ. Go ahead, Franco.
Hey, David, good to hear you. Good night to everybody.
Yes.
It's Franco K4VZ. Not much to report. Just one thing that I would like to clarify with the group and everybody else here. Since I saw the comment from Bob and 5BRG about Tangerine and Clementine SDR, I'm going to call that way. It would be nice to have a clarification with the group is where the Tangerine SDR ends and where the Clementine SDR begins, because I think there's a little confusion between the scope of the two projects. It would be nice to clarify where we are with each, because I think for the Eclipse, honestly, the Clementine may be right, especially for the first one in a few months. That's all my comment for now.
Very
Back
good.
to you, Dave.
Thank you. Next on the list is, let's see, Gary, AF8A. Go ahead, Gary.
Evening, Dave and everyone. I've been working on publicity for the grape, little brother, little sister, whatever, to the tangerine and whatnot. So that keeps me busy. Back to net.
And you have that motivation in the background there,
I sure do.
working for those eclipses. And next on the list is Jay, WB8SBI. Go ahead, Jay.
Yeah, good evening, everybody. Just didn't get a lot done over this past weekend in regard to software requirements for the software QSO party but a lot of personal stuff got in the way. I will be picking it up hopefully again tomorrow. Got clarified with Nathaniel about that there is a version control system out there which will be incorporated into my specifications. So I don't know who does or does not have experience with version control, but you're going to get an education. Anyway, that's about all that I have at the moment. 73 to all. Take care. Oh, and not this coming week, but the following week, I will basically be not available for anything. Here in Detroit, there's the annual Embedded Security in Cars Conference, which is the largest automotive security for cars in North America, that conference, the annual conference. So I'm going to be very busy attending that and learning about all kinds of stuff that people are using to try and kill you and what's being done to prevent that when you get in your car. And if they're not trying to kill you, then what there is going on to try to stop them from killing you. So I'll not this week, but the following week, I'll be very busy with that. Also got to keep in mind, we got to be getting ready for field day. Field day's coming up here, people. Got to get ready for the contest. So 7-3 back to net.
I will mention something else that's also on the same day as field day is the Software Defined Radio Academy in Friedrichshafen, Germany, and it will be broadcast on Zoom. So
oh, Friedrichshafen, nice place.
yes,
Been there, and if you ever get there, there's the Zeppelin Museum.
yes,
Which is right on the Bodensee, which is Lake Odessa in English. And they've got some really interesting stuff about the Zeppelins, because that's where it was. The Count Zeppelin was there, and they've got some very good antique radio equipment in that museum.
yes,
So Friedrichshafen, yeah.
yes.
And there's a good hotel on the lake, which has a very good restaurant, which I've been to. So if anyone's going there, I can recommend a hotel.
Well, it may be. Let's see. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Grape is plugging away. Nothing spectacular recently in the images. And boy, have I been busy with POTA and a local historic mansion. Back to you, Dave.
Very good. And next on the list is Nathaniel, KC3EY. Go ahead, Nathaniel.
Hi, everybody. I've been busy this week. There is a SAQ transmission happening on July 2nd at 9 a.m. Universal time. So I will be listening for that. That's that is 17.2 kilohertz. And I sent an email out to the list, and I also wrote up a blog post on the Hamside website. So I encourage everybody to try to listen and record if they could. I've also been working on stuff for CDR. I just finished up the poster, and I am currently working on a short presentation for Student Day, which will be a very basic introduction to natural radio and VLF and the system that is currently capturing it. Also, I've been looking at Internet of Things stuff. I kind of you know, I always thought of Internet of Things as a toy and nothing really useful. But I was thinking about for making the magnetometer more marketable, instead of it just sending data to the server, it could also integrate pretty easily with Internet of Things sensors databases that they have out there. Because I was looking at a particulate matter sensor and a gamma radiation sensor. They're all toys pretty much, but they utilize a Internet of Things messaging protocol that's actually very easy. Easy to use and easy to integrate, and people who might have those Internet of Things stuff running in their homes, reading data from sensors and generating different plots. They could also use this to integrate they could use the magnetometer data and actually see it on their own Internet of Things system. They could see the plots and understand them. They could monitor the remote temperature sensor as well as the axis values of the magnetic field. So it might be something to kind of market the that sensor. Other than that, that's all I have. Back to the net.
Okay. Next on the list is Majid. Go ahead, Majid.
Everyone, good to see you guys all. We here, we got our RX 888 module last week, 3 of them. And recently, one of our students, Rob, working on it. He installed the field software, and today I had a brief meeting with him. He said he had to optimize the laptop for the driver. So he's in there now, and after we finish with this laptop, we're going to give this laptop to all our students. and Rob is going to work with the PC that we have, and he has the access now to that PC. I guess that's it for me.
Well, very good. Keep plugging away. And next on the list, well, I've got two Robs. Go ahead, Rob. AI6VN.
Okay, can you hear me?
Yes.
Okay, I just have to, this has to be brief. I'm just starting dinner here. But let's see, I've been working on my Whisper Demon software and communicating a little bit with, about to start to work on the KA7Q radio integration with Whisper Demon. But most meaning, well, I don't know. I'm going to give a presentation. In fact, the two of us are giving presentations at the Friedrichshafen SDR Academy. So you'll see two presentations that are relevant. I mean, they're about, well, the first presentation is Gwen's showing the data we're gaining from the FSD4W reception reports. Gwen is being able to identify side scatter quite exactly. The paths, these side scatter paths are becoming quite easily identifiable, and we have two different examples of identifying paths. So we're pretty certain that the technique we're using, the equipment, the GPS stabilized transmitter and stabilized receivers, and 4W running on 20 meters and above can identify very clearly the path, and he's correlated it with the FARLAP calculation. So there was a paper being submitted to, I think, QEX on this subject, and Nigel and Gwen will be presenting the details of their analysis in a presentation at Friedrichshafen SDR Academy. So that will be available to you all. I mean, once he gets it up, you don't have to attend in live. They record it. It's up on YouTube, I think, and you'll be able to view it because the presentations we're giving are he's there at 11 a.m. I'm at 11:30, which is 2 in the morning here on the East Coast. So middle of the night for you guys. But all the information will be available later. But this is exactly the kinds of analyses and insights that I think we can gain from receivers like the Clementine, I guess is the name. So I hope you guys will have a chance. Most particularly, I'm just going to show how you can inexpensively transmit a WWV quality whisper or FST4W with a QDX and a Bogner. But Gwen's presentation shows what you can learn from from the FSD4W/Whisper reports that are available publicly on the net. So hopefully that would encourage people on research directions. There's details that we're seeing in the data set that suggests that there are other paths that we've never seen before. So there's, I think, a real possibility to do some good scientific research on these systems and the data sets that we're creating. So with that, I'm going to pass. I may come back. I don't know how long dinner will be. I'll come back maybe and join you later. But I hope, and if nothing else, everybody will look at the Friedrichshafen presentation, especially Gwen's. Back to Nick.
Very good. Thanks for checking in, and good luck with your travels. Next on the list is Tom in 5EG. Go ahead, Tom.
Okay, Dave, did you have another Rob in there?
It was the same Rob. One was on his
Okay.
phone and one was his video.
Okay, very good. I've been reading the mails on the RX888. That all looks pretty encouraging. This week, I've been focusing on testing the Tangerine receiver module, and I've succeeded in getting samples at 122.88 from the receiver into the FPGA. And the Verilog logic divides the clock by 2 and forms 32-bit words at 61.44 megasamples per second, which is 2 different samples, time contiguous. So it slows down the rate. Those go into an 8K by 32 FIFO, and the CPU is then at its leisure able to read samples from the FIFO. So we're getting real-time consecutive samples. The ADC chip that we're using has a number of digital test pattern generation modes. And one of those modes is a ramp that goes from negative full scale to positive full scale. And you can see the incremental samples. So that's good. A couple problems. The least significant bit is stuck at 1. And I've probed the ADC chip. It's right on the pin at the ADC chip, but it's not making it off the board somewhere. Unfortunately, the receiver is very difficult. All of the connector pins are inaccessible. The traces are on inner layers in a multi-layer board. And so it's real hard to find stuff. And maybe Scotty can loan us some unpopulated bare receiver and data engine adapter boards or something to help trace things. Secondly, the one of the channels, the clock is good, and I'm getting the samples from channel A. On channel B, the clock is about 1/3 amplitude instead of the full amplitude, and it's not enough to clock the samples out. And so that's indicative of a short somewhere, but I can't find it. I've been probing around using continuity checkers to see if maybe there's a couple of ADC pins that are adjacent that have a solder short or something. Can't find those. Can't find any adjacent shorts there. So they may be elsewhere. The schematics appear correct. So I think we have either an assembly problem or maybe a blown output driver on the ADC chip. So we made some progress. The receiver's starting to come alive, but until we can get the data and clock issues fixed, I can't really start running analog tests. So some progress. I think it points the way to being able to use the receiver module with the USB 3 chip, which might be a good thing. I'm doing it in Verilog in the FPGA. On an adapter board, it could be done using discrete logic. It could be done using, a small PLD device or PAL device that is fairly inexpensive and just has, tens or dozens of logic blocks in it. So nothing too significant. So anyway, that's the week. Back to the group.
Well, very good news. Thanks for the work, Tom. And I think that brings us to the end of the list. So we're open for general discussion.
I did want to point out the notes document that I put. There's a link in the chat, and I could try to share the screen if someone wished, but I don't know whether I can do that since I can't even show my own face. So, but it's all about trying to make some decisions that probably need to be made along the way about the USB 3 based receivers and where we want to go with that. I'd love to get some feedback. Further feedback.
I have your document up, Dave, and it looks good. You should be able to share your screen, and if you can't, I'll be happy to share mine.
I'll try. Let's see. Can you see that?
Yes, we can see it.
Okay, I can't, but or at least I can see it here. But yeah, I just tried to make notes. I wanted to basically, I went back to Tom's early architecture and system requirements document. Looked at a lot of the existing documents that relate, I assume, to the grants as well as everything else. And trying to look at ways to preserve as much of that as possible. For the radio subsystem, I wanted to implement as much of the RF receiver module as could be. One approach is to make as much of that available as possible, though the functionality, but using the RX88 devices, 888 devices. But there's some questions about how to integrate that. One thought would be to create an adapter that would take the existing boards that Tom was just talking about and pass them through to USB 3. He just made some comments that seems possible. I'm not sure I understand all of what would be involved, but it seems like it would be good to try. And one of the little board that Cypress has always sold, the developer kit board, had some add-on boards also, one of which was a CPLD. And there's a book even that gives practical examples of using that board as exercises in learning how to use this developer kit. I've tried to find one of those boards, and as usual, Newark, UK claims they have it, but they can't tell me. They can't even tell me if the things I've ordered are even. They can't tell me anything. They don't know. They don't know nothing. But I've had much better. It suddenly occurred to me that I was sitting in my office that I've kind of moved out of, and I saw a nice blue box over there. I couldn't remember what it was. And it turned out to be one of these developer kits that I had bought before the Tangerine project even started. I have somewhat of an excess of such things. So at least there's one in hand, and there's one on order from Newark, and there's 3 on order from AliExpress. Hopefully we'll have enough for more than one of us to play around with it. Hopefully someone knowledgeable to try and implement some of the features that might be useful. But that's if and when we wish to go down that path. One choice is to integrate toms. One choice is to create an adapter. One choice is to work with the RX88 directly and try to squeeze as much relevant performance out of it as possible for the purposes of this project. Another is to build a controller that interfaces to Tom's boards and again do as much, extract as much out of those as possible. And the third is to develop a customized variant of the RX88 that is, adds and subtracts any features that seem appropriate to the project's needs. I don't think these are difficult boards to manufacture, and they probably could be gotten to the point where they could be done pretty quick term. But I don't know whether there's enough things there that could be improved and to be worth that effort. I was trying to be prepared if people decided to do that. There's also the, you know, the software integration. We need to do, we need to verify that all the drivers support the kind of use we wish to make of this, and that we can contrive to capture this data into the online repositories that we're trying to build. The K9Q radio components seem to be a very interesting way to go, but I think there's still some unknowns in making smooth installations from those. People are still working on documentation of that, but it's getting better. I thought that we really need to make sure that all the Tangerine stuff is really archived in one accessible place. I still don't know anything about the Zenodo stuff. I don't know what Zenodo even is really. And I don't know what some of the great people have done with their documentation, but I'm a GitHub kind of guy. So that's more my stuff. Need to get a lot more experience with the configuration of K9Q radio, documentation, that characterize the strengths and weaknesses of available boards. Make sure that we can do something useful with RX 888 type devices. I think the general sympathy, the general sentiment seems to be that we can. And I have started porting the existing documentation, existing schematics into KiCad or KiCad, however you wish to say it, with all the, so that we have a base base schematic capture that and board design that we can play with as we consider options should we wish to do that. And some of those things are putting a better front end in front of the, I think as people stated, in front of the ADD, similar to what Tom has done. Integrating the clock, the clock, the discipline in the clock, that seems like a hardware thing. But getting some documents we can discuss, and KiCad is available on all platforms and is free, and I would hope it would be acceptable to the majority of folks. The ORCAD that we were using before is Windows only and heavily licensed. And so I still don't have schematics of a lot of the Tangerine SDR stuff. But I think we can derive a pretty complete schematic from a couple of documents that exist, and have a hardware documentation what we're looking at. GitHub repo. And I've been accumulating the tools that, from my perspective, seem useful for this kind of, for all of this. I have in hand one SCI USB kit 003, which is the basic developer kit. I'm trying to get one of these 007s that has an outdated CPLD. Newer claims they're sending me one, but who knows? And AliExpress does not seem, I have not found them on AliExpress. Currently Infineon, it has me so screwed up. Well, yeah, they won't let me download the software, developer software and stuff, but I'll get that. It's out there. And there's some books that are helpful, especially this super speed device design by example book that you can get printed on demand from Amazon. That looks, it's not a great book in some ways, but it's a great book in that it tells you what you need to know, I think. And the classic USB complete version 5. Hopefully there'll be a version 6 one of these days that covers some of the newer developments, but 5 covers super speed and super speed plus. I have a couple of ADC development boards. I'm not sure. One of the questions that seems outstanding is, should we decide to build something of our own, what ADC do we want to use in there? And I have one that Tom is working with, I believe, I think it's the ADC 9648. I have that on the board. And I also have an LTC 2208 14 board. But I don't know what anybody wants to do from there, or if we want to go that way. So those are just my notes about what's where the physical parts of this are going, and they are, that link is a download link for a PDF file off of the Pycomation server, off the magnetometer server, that should be accessible to everyone. You can just download it and keep it if you want it for anything in this document. And there with all the data. It's I'd just like to get reactions to this. I've gotten some from Rob and some others, but I'd like to know if I'm putting my energy in the right places or doing something, should be doing something else.
Hi, Dave. This is a great list of things to look at. If I look at the project, just kind of reflecting on the way we could do things, in my view, getting to a working anything fast is probably one of the highest priority things we could do. And in that regard, the RX 888, which has the A to D in the front end and the USB part already done and functional, is an important thing perhaps to do initially. What we develop as a result, the software and Phil Carnes stuff and the interfaces and the drivers would be needed anyway if we were to roll our own. If we were to put our own A to D and some magic glue logic into a USB chip, we would still need all of that. There might, you might have to make a few tweaks or changes to the software, but it would be primarily used. And so I'm wondering if a good sequence of operations here is to try to use what we can get our hands on to most quickly get something up and running, and then run maybe as a secondary task, how do we merge into that with some hardware maybe that has a few extra features we need or a few extra functions, or, is there a way to modify the RX 888 to do what we want to do, to time mark, to frequency lock, those kind of things. And we could kind of explore that in parallel with, something that gets us there quicker. Does that make any sense?
it makes total sense to me, and I guess one thing that doesn't come through here very well in my document is that I agree exactly with that order of that, order of marching from one thing to the next. We ought to get what we can quick to work as well as possible. I don't think we'll waste a bit of effort, waste anything by doing that. And the only thing I don't know is from Nathaniel, what if he's feeling any pressure to have a custom hardware solution in the final documentation of any of these project, any of the grants. I just don't know.
Probably
That's not my.
does it not depend kind of on whether the RX 888 meets the specifications necessary? I remember we agonized a lot about the specifications of the Tangerine way back when. And is the RX 888 able to meet? And I'm not talking about timing, but
it doesn't. It's certainly not everything that's in the document that Tom produced. The coherent dual channel coherency. I don't know what all else, but it's not as great as the original conception. But whether it's enough to do good science for now, that'll please granting organizations and us is a different question.
Well, I already have, yeah, so I agree with all of his comments. I think this is a great list, Dave. So I do think we will be able to do some good science with the RX. I think we'll be able to do some good science with the RX 888, or we might be able to start. I don't think it meets all of the requirements that we laid out in the original TangerineSDR. I already have a student and a part of a student tasked with trying to use the RX 888 as like a TangerineSDR or as a personal space weather station. So there's already students in Majid working on trying to get that software running. So I would think if the students can work on getting the RX 888 going, I think it would make sense for Tapper to try to work on developing hardware that meets the requirements as closely as possible.
Good. I've just said about trying to determine the availability of the pieces to do those things, I guess. Yeah. And in many cases, that has meant just getting them. So I've got RX 888. I know there's at least a couple more here. You've got a bunch of them. So a lot of us have already decided to explore this path, at least personally. And hopefully with some, if we figure out a way to timestamp if you can figure out two things on the timing, one, to at least discipline the RX 888, which seems pretty straightforward. And the other is to timestamp the data that comes out of it. I think those are two separate issues, but and the latter might be a software issue that needs to be explored, possibly in the Cypress device, because there is, I don't know what kinds of things you can do in there. It is a programmable device that has interesting capabilities. But yeah, that's exactly how I'm thinking. And I want to leverage anything that we can from Tom's work too. But yeah, there's some ideas for making a better radio in the end, but probably that would run with almost the same drivers.
Hey, David, this is Franco K4VZ. I wanted to make some comments just because I'm kind of new here, but maybe help put the perspective on the whole project.
Sure.
So my first comment is that I was involved here by Rob because basically they need with the Kiwi SDR going out of business, no longer being manufactured. They were looking for something alternative to that, and that was the RX-888, and then of course TangerineSDR. So my first question to the whole group is, what is your target goal for the TangerineSDR as in terms of price, availability, and so on? In other words, I noticed that RX-88 sold for $150, $160. I'm not sure what the TangerineSDR will be, if we were retail or it's just a research tool for, university academies who can have grant or so on. It's not probably a replacement for the Kiwi, but it's what do you envision on that side first? And the second issue, again, is the timing. So do we are looking something for the eclipse in October, in April, or something more long-term, or what is the actual goal of the project? Because I mean, honestly, I'm new here, so I'm trying to, wrap my mind around to the whole goal of the TangerineSDR or ClementineSDR and so on. So it's a more question for the whole group. On the other issues of the FX3, I have the book that you mentioned, John's. I forgot his last name. So it's a pretty good book. The application note from Cypress / Infineon are very good, in my opinion, actually very well written. And the other thing I was thinking, again, this is another project I saw around, is something called the Red Pitaya / TRX Duo, which has the two LTC 2208, which could be closer to what the Tangerine wants to be, and is only $270 on AliExpress. That was my comments.
So I think the target price written in the grant was originally about $500. If we can do it for less than $500, that's certainly better. So we're not trying to make something super expensive. Yeah.
No, what I'm saying is the price, basically, the number of people who are going to get it's exponentially on the negative of the price. So if you increase the price from 200 to 300, you get, 1/3 of the people and so on and so forth, something like that,
Yeah.
So it's very important to keep, I mean, at least in my opinion, if you want to do ham science, citizen science, you probably want to keep it in some range. I don't know if there's maybe more sense to make a Tangerine light or something like that. I'm not even sure about that.
Yeah, well, that's why, and part of it is we had the grape, which is a low cost. And the original thought was we have the grape, which is a low cost version, which is supposed to cost around $100 or so. And then the tangerine was supposed to be this really more high end thing that would almost like replace the Edis. And we wanted to do that for around $500.
Okay.
So that was the original goal. So if we can stick to the original requirements that are written down right now for the original Tangerine, if we can meet those requirements for $500 or less, I think that will be really good. I don't know if that's possible. Same thing with the timeline. Can we come up with something that meets those requirements in terms for October? I don't know about that. If we could, that would be awesome. But I think what would be really great is if we could, I was hoping we would be able to meet those requirements that we had written down in the requirements document.
The other thing, are you done, Nathaniel? Sorry.
Go ahead.
You done? Yeah, no, the other thing to consider is that what you would get with $500 in 2019 or 2018, now, with the Chinese making this stuff day in and day out, you can probably get now with $300, or something like that, at least from what I can tell. So especially because they can get those LTC 2208-16 for $15 each, so they stack 2 or 3 of them in one and they get you, going like that. That's how they do it.
I will mention that several people have the Red Pitaya boards. I know Nathaniel has one, I have one. And there are probably some other people on the list here that have them. I use mine as a whisper beak receiver.
Yeah, so do I. So if we go back to Dave's list, with those three options, one was basically using the RX-888 as it is, right?
Yeah.
And so we're already doing that. Like that's what the students at Scranton are already supposed to do.
Okay.
Okay. So then that leaves us with the other two choices, which are one, use what Tom has already produced, or two, create a brand new receiver design. What would be, now I would instinctively think we would want to just use what Tom has already created, because I know he put a lot of work into that, and I think that, you know, what's that? Hello?
I don't know who that was.
Yeah,
Dave,
it looks like Dave may have dropped offline.
yeah. Yeah, I don't see Dave on the call
Yeah.
now. But I guess,
He'll try to get back on, I'm sure.
yeah.
Yeah, so Nathaniel, one of the other option I thought of is we come up with a list of modifications to the RX-888. You know, maybe we can meet a lot of the requirements with, you know, skillful use of X-Acto knives and drill bits and things. I don't know. That could, that's kind of the third option. Do you have another option?
Do I have another option?
Yeah.
I mean, those sound like the main options. Use the RX-888 as it is. Yeah, modify the RX-888, create something new, or use what you already created.
Okay, so we have four options then.
Yeah.
Okay.
Or I guess the fifth option is use something like you know, a red pitaya, something totally different.
Okay.
What do you have a gut feeling, Tom?
The receiver, well, we have, of course, John's clock module working, and
Right.
it's been pretty well characterized. So that, you know, and it's small, that can be expensive for high performance. And he had a couple of less expensive versions planned, I think, but we've only tested the high performance version. The receiver, you know, I'm partway into testing it. I have no analog data of any kind, but I'm using pretty standard parts, you know, the LTC 20 dB preamp or ADC driver preamp, the dual channel A to D. When we priced it 4 or 5 years ago, it was like 40 something dollars. They got 2 A to D converters in one package. But again, it's 14-bit, although it has just about the same performance as the 220816. It's close anyway. So it's hard to say. If the receiver that I've got, the problems are just, you know, soldering issues and things like that, then, you know, we're almost done from a receiver module and from a clock module. And we have to basically put some logic between it and the Cypress part to precision time marks to get coherence and to spread the sample rates out into 32-bit samples so that the Cypress part can handle the data rate. So gut feel, I don't know, you know, Scotty should have the cost of the receiver module and the cost of the clock module. We might want to query him if he's got that data so that we at least know the cost of 2/3 of the system. And then we have a straightforward path, I think, to getting to a working unit. I don't know how easy or hard it would be to pack up the RX-888. we could certainly go into the board and insert the clock module to get much more precise timing.
Right.
Don't know how we mark the phase coherence on the channels. That's an unknown right now. And maybe that's easy or maybe that's hard. So
Mhm.
there's some unknowns there. So I think that's the set of trade-offs we have. And from my perspective, I'd sure like to get the cost numbers from Scotty first.
Mm.
There is a plug on the RX-88 that allows you to put an external clock to it. I took a look at that. And
Yeah,
it
it's
gives
a,
number out.
a 27 megahertz.
Right.
Yeah, the clock module can be reprogrammed over the I2C to put
Yeah.
out anything that's needed. We've chosen particular frequencies that we know have very good phase noise and Allen deviation performance. But they wouldn't degrade that much by going to something else. My question is, how do we time mark the samples from different RX 888s? Can we kludge a little logic circuit in there to do it? We might be able to. Can we, that's what we'd have to look at.
Hey, it's Franco here. I was thinking about what Rob said last week about Phil's idea, which was to inject a signal with the timing. So since Phil can receive, 2,500 channels at the same time, you can put one channel with the timing. And of course, that will be your reference because it will get processed the same way as all the other whisper channel. Make sense?
Yeah, so that would be an analog insertion into the front end of the receiver.
Yeah, that's what
Right.
Phil's idea was, because he can do that and it would be, free pretty much,
Yeah,
hardware wise.
yeah, that's a solution. I don't know if it has the precision that a digital solution would have. It might be just as good. It might not, but at least that's good in that it's doable. And the modifying the RX 888 has the least worries about, fitting into the project that Nathaniel's students are working on. So to me, that's the easiest way to go forward, is to figure out how to take a clock module and, branch it into the receiver. The other thing that's missing is the Dickey switching, where we insert using relays, the noise source for calibrating noise performance. But we could build an analog module that would do that and also insert the reference probably at the same. So that would, possibly be a doable analog module.
Mhm. I mean, I think, are you still able to hear me?
We can hear you,
Yeah.
but your video's frozen.
Okay. Yeah, I'm on a hotel Wi-Fi, so my Starlink is better. Yeah, so I think the thing to do is to keep having the students use the RX 888. Just keep moving ahead with that. I think if we can, if it's not hard to modify it, maybe have them do those modifications or make those modifications. But I think if it's cost effective, I would still really like to see your RF module and the clock module, be used in this project. I mean,
Okay.
we design these things. So your clock module has the coherent channels in it, for one thing, right?
Yeah, the clock module, is the GPS receiver, the synthesizer, the high performance crystal, so that it has some kind of holdover capability,
Right.
and has pretty low phase noise. So it's a fairly high performance clock.
I mean, those two circuits were designed with the requirements in mind.
Yes.
And if we just throw that out, we're throwing out a lot of work that has already been done to meet those requirements, right?
Yes, we would be, but it's still an open question, which path is faster.
But if we have the students working on this, on the RX 888 path, why would we not still go forward on trying to meet those requirements?
Yeah, if they can work on modifications to the 888 to pick up some of the needed features, then that's, a well isolatable separate task from reusing the clock and the receiver and doing a new adapter widget board. And so, if we want to pursue those in parallel, I think that's an efficient process.
I think so, considering we have the people that could do it. Like, I think the students, they would probably need some guidance on how to make those modifications. Would you be able to provide that some guidance with that?
Yeah, I can provide advice. Those who are actually using the module, I don't have an RX-888, and so I don't have a circuit board. I can't, say, put your drill bit here and, tap into the signal, or, gee, we can do this without any modifications at all. So, that's real easy for the students to do.
Yeah.
Not having one in hand makes that a little challenging, but certainly I can advise on, good ways to do that. And if they can be done in a no scar way, that's the best kind of student project.
And Majid is working closely with the students. And so I think he also would be in a good position to do these modifications or provide advice or,
Yeah.
There's a schematic online for this RX-888. And
Okay.
I do have 3 of them in my hand. I can open up one of them carefully and, just if you guide us to, where to, do those modifications through that schematic, I think that would be doable.
Yeah, I looked at the block diagram, but I didn't, I don't have the schematic. It may be in all the links that flew by last week. One of the things that, it has an external reference, and then it runs that into a synthesizer chip to feed the A to D converter. And I don't know the performance of that. John Ackerman's our expert there. We might want to ask him that question. The no scar modifications to replace the 27 meg reference clock. The other mod is to go the output of that thing and substitute the TangerineSDR clock module, because it's got real good, real clean outputs. But, either one might be good. So yeah, we can, the block diagram, it looked like it was easily doable. I don't know about the sample rate. The current RX-888, I don't know the rate of samples that we'd be putting into the receiver. And if we have to run that at a different sample rate than Tangerine ran at, but that's okay. We can work our way through that and try to come up with things we can do to the 888 that get us as close as possible. Maybe not to 100% of the requirements, but to a bunch of them. And then separately work on something that gets us a lot closer to 100% that uses the existing modules and maybe one new module. And if we can do that, that may be good enough.
I think that's good. And I do know, I did talk to the program officer. If we need another no cost extension, we can get another no cost extension past this December 31st.
Oh, excellent.
So I do really, I do want to see the RX-888 solution come through. I do really want to, I really would like to see the work that you've done come to fruition as well.
Okay. I think to me, that's a good approach. You get something more quickly usable in eclipses and things that are coming up, and providing a basis. It's always much easier to iterate a design than to do everything from scratch.
Right.
And so if we can get the RX-888 up and running, satisfy Rob's requirements, and then as a second pass, iterate all that into the more Tangerine-like solution. I
Right.
think we got a better chance of getting there.
Yeah. I agree with that.
There was one question that I had about all this. Nathaniel, I remember that one of the goals with Majid and the students is to get Phil software working with the RX-888 to try to emulate a grape.
Yes.
So the grape makes Doppler shift measurements.
Mhm.
So how would that be done with the RX-888 using its own clock? So, because I was wondering that myself, like you know what's actually in the
Well, I guess you mean, I guess when I said that we would start by having the RX-888 be like a grape, I didn't really expect it to make grape quality measurements with its own clock.
because I mean, like, so
If
so are you working towards
the idea is that was a stepping stone, because we'd have to do that software development anyway. So we just use the RX-888 as a stepping stone, and then once the Clementine or whatever with the good clock was ready, then we would just transfer that software and that configuration over to the Clementine.
But doesn't the grape has a Bogner as part of the system, correct?
The grape does, yes.
Well, then
Grape one.
take the Bogner and feed it into the 888. I mean, it has an external clock input, and the Bogner can set itself to 27 megahertz. And
Then-
that's what Glenn N6GN is doing.
Then I guess that will work.
Yeah, I mean, you get Bogner stability out of it.
well no my question is that using Phil software, how are you extracting or how would you actually extract from the slice IQ stream Doppler shift measurements?
Yeah, the KA9Q radio software package does that. Translates the IQ stream and produces the demodulated audio outputs, and many different demodulators are already implemented there. And the accuracy of the demodulated audio or the demodulated frequency is entirely dependent upon the accuracy of the Bogner feeding the 888. So you'll get the same level of frequency accuracy out of the 888 when fed by a Bogner. You'll get the same frequency accuracy as you get out of the grape.
Oh, no, I understand that, but I mean like the actual software, the actual software methodology to extract.
That's this package, the KA9Q radio package, that is a software service that takes that sample stream and produces the potentially hundreds of output streams and in fact, there's such a system running out at KFS right now that you could attach to and log on to. And it doesn't have a Bogner feeding it yet. I haven't had time to do that. And I don't have a spare Bogner right now. The Bogner I have out there is feeding the Kiwis. So, but you'll get the same performance out of this package. The 888 plus the K9Q radio will give you the same frequency accuracy and signal noise and performance as you get out of the grape.
Right. No, that I all understand. But what the grape is doing, the grape is mixing the GPSDO with one of the carriers from one of the time stations. And the output is an audio signal. And what the grape actually does is it monitors the frequency of that audio signal. It'll actually plot it and generate a plot of the frequency, or the frequency deviation, I should say. And it also generates a plot of the amplitude of that signal as well. So those are the two data products coming from the grape. So with that in mind, a software utility will have to be created to take the frequency to record the frequency deviation from the carrier, and then output that to a data.
I believe that the one task involved in the 888 is taking the audio stream, the 99 kilohertz USB audio stream, and taking that audio stream, which comes out of KA9Q radio. You need to get that audio stream into, what is it? What do you use to capture that audio stream? You're using FL Digi or something?
Yeah, right now they're using FL Digi.
So
but
that is the one task, is get the audio stream, which is a multicast RTP multicast stream containing the audio samples, to get that and feed it into a FL Digi. That's the only thing that needs to be done.
No. The reason why that there's the grape mixture board, it generates an audio output, obviously. So you could use a standard sound card to make those measurements, make those frequency measurements.
Yeah.
But no, I'm not talking about any demodulated carrier, because it's not doing any sort of audio demodulation. It's only comparing the carrier frequency.
Jonathan, as long as you know what frequency bin the carrier, the signals are coming in on, we'll be fine.
Well, right. But what I'm saying is that you're going to have to create a software utility that can take that information and output the grape style data.
Jonathan, I don't think we necessarily want grape style data. We want digital RF.
Yeah.
And I have an RX888 on order, and I'm going to see if I can hook it up to GNU radio to output digital RF, just like we're doing with my grape.
Okay.
I believe it can be done.
By the way, are you aware that Clint, KA9OEI, has a blog page with instructions on how to do all of this, everything you're describing?
Yes.
So his page is based in, of course, he hasn't figured out everything about it, but I would encourage you to communicate with Clint as you work with the device. Between Clint and Franco, I think you'll find there's they've investigated and solved many of the questions that you might encounter.
I'm sure we can get it working just like I've got the grape working with DRF today.
Yeah.
Well, Bill, but what you're doing is you're taking that audio signal from the mixer and you're just recording it as digital RF, right? That's basically what you're doing.
Well, it's not quite that simple. There's some signal processing involved being done in GNU radio.
Well, what is it doing?
Oh man, I'd have to show you this flow graph. There's several steps involved. There's filter and
It's 10:20, and I'm afraid I'm going to need to go. So
Franco has posted up the links in the chat there to the blogs and to that. And Jonathan, I encourage you to go look there. This combination, one path is 888 plus K9Q radio can generate a stream that looks identical to what comes out of the Grape mixer. It's baseband audio. And so, you know, at that point, it can be processed any way you want to process any other baseband source.
Yeah,
Right? I mean,
I'm pretty confident we can get the output we need.
yeah, I don't think you,
from what I've read, yeah.
yeah, and you don't have to go into K9Q radio. If you're only doing one channel, then New Radio, CSDR, there's all kinds of command line tools.
Well, you know, Stan up in Massachusetts, he's running multiple GNU radios, and they're getting multiple channels out of a grape. I mean, so they got 3 grapes hooked up to you can do it on multiple channels at once. It's quite doable.
Yeah, there's plenty of ways. The key is to have the ultra stable reference oscillator.
Right.
After that, everything is a matter of processing. We should let Nathaniel go anyway.
It's getting late.
Okay.
I'm running down as well. So.
Okay. I will be traveling then, you know, for almost the next month. So and it'll be middle of the night for me. So I won't be a live participant. So
good luck in Friedrichshafen.
Well, yeah, thank you. There is also a question about, is there a reflector for this group where we can, right now, there's an email chain that I think doesn't include everybody who might be interested in all the conversations.
Yeah, if you, there's a TangerineSDR listserv.
Okay. Could and do you have that email address? That
I do. I'm looking at.
Don't stay up late to do it.
If you go to hamsci.org and click on Get Involved, there's a section that says TangerineSDR listserv.
Okay, fine. I'll find that.
Great.
Okay.
Thank you, everybody.
Okay. Take care.
Have a good night.
Nathaniel?
Yes.
Quick question, Nathaniel. With next Monday being a federal holiday, Juneteenth, you still plan to have the call?
Oh, I hadn't thought about that.
Okay, just send it on the mailing list if you do or don't.
Sounds great. Okay, everyone. Thank you. Have a good night.
Bye. Get some sleep.
Bye.
Good night, everyone.